yeah, now it's a piece moving about. So let's see, when it hit the bottom, it should like stay there. Yeah, that should be cool. So let's see if it the bottom. Let's see how many times the message is written out. So let's see here. Yeah, so you can see. So basically what we want to do is when we hit the bottom, we want to call a new method, or we want to set a new tetramino. So you can just say this new get next, or maybe set next tetramino. So that's simple enough. We just want to go up. Yeah, let's do it down here, or maybe above. So you say set next tetramino, set that equal to a function. Then we just grab this logic and put it right here. And then instead here we just want to say this dot set next tetramino, like that. Let's see here. Just want to make sure that we set as it should be removed, right? Let's see what's all happened. Yeah, it should must so we should need to set it to the thing as well. So we say set to BC again. Let's see now. So now the pieces should be falling down and then stay there, and then the new piece should be coming down. So let's see. And when that hits that piece, it should be moving down and it should be working as it should here. So that's cool. Let me just take a quick break, guys, and I'll be right back with the continuation from here. Yeah, so I'm back, guys. So I don't really think this line of code is necessary, so let's remove that. So let's see if it works anyway. Yeah, that seems to be working fine. Anyway, just to make sure, why not set the Y position to 0 as well, and do not forget to import increment the tetramino here in the stat manager. So if you remember, we have this increment tetramino method on the stat manager. So we say inc tetramino this dot current tetramino dot id, like that. So let's see. Yeah, you can see that it added a 1 here to the set piece. And I just saw that they are actually in the wrong direction here. So yeah, well, we'll fix that later. Anyway, let's create some more movement definitions. So I have to move down. So let's create move left as well. And then we have move right, of course. Then we have move rotate, like that. And all of them will need to more or less make this a check here, so we can just paste that into everything here, like that. So we have that noticed. Okay, so move left, that means that we want to go -1 in the x direction. Move right means that we want to go one to the right. So just change this to x, this to a minus. That should be it. And then for move rotation, it's a little bit more complicated, but here we just want to say, let's say that it will take a direction in which it can rotate as well. So we can say it should be equal to dr or 1. And here we just want to say 0, 0 dr, of course. And then we say ctx dot rotation equals ct dot get rotation dr. I think that was what we called it, right? Let's see. Get rotation, yes. So everything we need to do right now is just to map everything all of those to some event. So we have already the automatic movement done. So we say input dot pressed you can say up. Let's copy this a couple of times. And here we have down, maybe left and right like that. So let's just add on implement all of those. So if we press up, we want to rotate it, so we say move rotate like that. If we press down, we want to say move down. Of course, this does move left. And lastly, this does move right. So let's see. You should be able to control piece and rotate it as well. Yeah, that seems to be the case here. And I can press down to make it like move quicker and other stuff like that. Well, as you can see, even if I get a full row like this, it won't like empty the rows. So let's implement that as well. So for doing that, we'll need a new we'll add it here to the move down here. So we will say what do you say? We want to check the rows. So you say this dot check rows. So let's create that method. So we say check rows. Won't take any arguments like that. So you just want to say have two variables, a boolean value that we call full, then a removed variable that will count how many lines we clear. Anyway, so we just loop through the block control, but from the top, from the bottom. So we just do it like this instead. A regular looping here. Then we just want to set the full variable to true. Then we just want to loop through every block in that, or every column in that row. So we say j is less than this dot calls j plus plus. Then we want to say if this dot block control, add j and add I. If that is solid, then we want to set the full equal to false. And we want to break this for loop. And then here we say if we have a full line still, then we just want to remove a row. Add I like that. Increment removed count. And then just update the statistics of how many lines we have cleared. So let's just add that post here to the stat manager. We'll also keep track of the level and the score here. So just add all of that to the stat manager as well. Sorry for that, yeah. So here we were. So we just increment the lines, and then we just want to increment I here, so that we check the next row and so on and so forth again. And here we just say if the removed lines, if I've removed any lines, so if that's greater than 0, then we just want to add this some score to, so we say add score with how many lines we have removed, and then we want to check if we should level up. And those two methods we will have on the stat manager as well. So let's just create them right now. So say add score lines cleared maybe, and check level up. So that should be it. Let's just do it like this. Yeah. So the one method we don't have implemented yet is this remove row one, so let's create that. So just like this, and that will take which row we should remove. So just for convenience, let's just grab the block control, so say this block control like that. Then we set I equal to loop from I, then we will loop upwards again, but not all the way up. So it's really important here that we have greater than 0, and here we have greater or equal than 0, because basically what we want to do is we want to copy the value, the line above the line we want to remove, and drag that one step down. And that's exactly what we do in this line of code here. So say j is less than this dot calls j plus plus, and then you say bc at ji is set at type to the bc j at I minus 1 dot id, like that. And that should now actually work here. So let's reload the page, and we got some errors here. So let's see, Tetris 131 here. Yeah, J. Let's see here. I do my best here to play quick. We'll probably implement a hard drop functionality to the game. That's quite good. Yeah, so now you can see that we can remove lines from the thing here. So let's see if we can clear 2 lines in one go as well. Yeah, that seems to be the case. So that means that this works at least. And you can see here that I can snipe in pieces, and game is actually now starting to take some real shape here. But probably not that fun to just get what do you say, the set piece all the time. That's quite annoying. Let's just check here what the SPs look like. Oh, the SPs and the ZPs look the same. I probably have something wrong in the shape definitions. So let's see here. Yeah, they were the exact same thing here. So it should be, the Z should be like this. Not like that, oh. Well, yeah, that should be it. Let's see. Yeah, that's now the right piece there. Good, we fixed that error. That was quite annoying. Let's actually now when we added those things to the stat manager, let's actually increment the scoring and level up and all the stuff like that. Anyway, so this scoring in Tetris is quite complicated. It depends on which row you are going on. If you get clear a row for the first time and all stuff like that. So I'll leave a link to this post in the description where you can read more about the scoring. But anyway, the way we will implement it is we will need to check if it is the first time we level up. So we just set that equal to false here when we call the reset function. And we also need to keep a reference here to the start level. So we say start level, and that's just equal to the start level of 0, where the start level here is an argument to the function. So we say like that. And then we just set the level is equal to this dot start level. Close. Let's just move this down here. Like that. So basically what we want to do when we check for level up, then we want to just check if we have incremented the first level. then we just want to say if this dot lines is greater or equals to this dot level plus 1, oh sorry, times 10 plus 10, like that. Actually we can do it, yeah, this looks better. Yeah, that's the same thing. It should be right. Let's see, they add a formula. No, this is for the scoring. Yeah, anyway, this works as well. So if that's the case, then we just want to increment the level like that. Else we want to check if this dot lines is greater or equal than this dot start level plus 1 times 10 or 100, because 100 is the maximum starting level you can have. Anyway, then we just want to set this dot first level, set it equal to true, and we just want to increment the level, of course. So that's it for the when we want to level, how we want to level up the game. And then for calculating the score, it's just as simple as we want to say how many rows we clear in a row. So we have 1 clear row, 2 clear rows, and then a triple, and lastly a Tetris when you clear 4 continuous rows. So you can just get that score like this. So if you clear 0 rows, then it will return 0, and so on and so forth. And then we just add that to the score here. So we say score plus equals this dot level plus 1 times p, like that. And we now have all of the scores drawn to the game. Anyway, we probably want to see the level lines in the score though to the screen, so let's go back to the game board now actually, and let's implement or let's draw the scores to the game here. So we already have a reference here to the stat object, so everything we need to do is just say this dot font dot gray dot draw through context, and we now want to draw the stat or level, and then at some position, let's say 120 maybe, and want to pad that by 5 zeros. If you, yeah, and I just got that from the repository where we took the boilerplate for this game. Anyway, and then let's say that we want to draw it at 30 and at 50 maybe, like that. And then this should be changed to the lines, and this to the score. So let's see what it looks like. Yeah, it's quite good. Not really where we want it though. Change this to 80, 110 maybe. Let's see. Yeah, it looks quite good. Maybe a bit smaller here. 78. And maybe a bit bigger here, let's say 12. See what that looks like. Seems that we should have maybe 1 more pixel here then. Yeah. It should be down a bit. See, that's perfect. 35, let's call it 15. Nope. It should be up 1 and it should be probably down 1 then. Yeah, so that's perfect here. So here we can see that when we clear lines, this should be updated here as well as the score. So let's see. Hopefully now when I clear this line, I should get 40 as a score, and I should clear 1 line. So let's see. Yeah, so that worked. I had some misspelling though, so let's see. Stat manager level 51, line 51 should be this again. I really can't spell this. Anyway, so I really think it's quite annoying to like need to tap the down button all the time to make the tetramino go down. So in Tetris you have a concept that is called hard dropping. That will give you some score, and that will drop the piece down to the so much that it can when you press the spacebar or any other button on the keyboard. So let's implement that in our game as well. So let's see, we can here in the Tetris game, I should say, where we do all the moves, let's have another one that we can call hard drop. So let's create that method, and it's sort of the same thing as the move here. So let's just grab all of these. It's sort of the same thing as the move down, just that we want to do move all the way down. So you say while move like that. And we just want to set a variable called move here to true, and then here we want to set move equal to false, and stuff like that. And here we just want to increment the score, so we say this.stat.score plus equals 2. So when we drop from a higher altitude we get more score. Anyway, so let's add that to the spacebar. So you can also say if input.pressed space this.hard drop. So let's see if that works. Yes, you can see that I get some scores, and that I can move the pieces all the way to the bottom without needing to press that much keys. But anyway, let's finally implement the way where we get different types of tetraminos. So the concept is very simple. You can think of it that we will create a generator that we will have sort of like a bag of pieces, and then we want to draw pieces from that bag. Until they're empty, and then we want to throw in all the pieces and shuffle the bag. So that's sort of the random algorithm they use in Tetris. So you always get a good distribution between the different pieces. So I will call this randomizer. So let's see, randomizer like that. So let's just implement it here as well. And you can say this or random equals new randomizer. That, and then each time we reset a game, we just want to initialize the random generator, randomizer. So let's create it. So create a new file, randomizer. .jas, yes. So let's define it. Class.extend as usual. Yeah, this should be good here. So the constructor, it will just give us we'll just create an ID of all the list of all the IDs. So we say all the different pieces, we have the LPs, the IPs, the TPs, S, Z, O, and G pieces, and you just want to split them like that. And then we want to how many different pieces we have. So we say this dot size maybe, and we just set that equal to IDS dot length like that. And then we just want to call the initialize method like that. And this should of course all be in the constructor, which I forgot to add. Let's see here. Like that. So let's create an initialize method. like this, and then just set the index on where on the bag we are, like to 0. And then we just want to create a bag, so say a new array, this.size, with the length of the how many pieces we have. And then we just add all the different numbers to the bag, like that. And then we just want to shuffle the array, so we say this.shuffle, like that, or shuffle the bag. So let's create a shuffle function or method. So that's simple. We create this reference to the array that we can put in as an argument. So we say that's equal to the array or this.bag, like that. Then we set the counter to the array length, like that. And then we have a temp variable and index as well, like that. And then we just say while the counter is greater than 0, we just want to set the index equal to the math.random times, what do you say, the minus the counter here. So we want to subtract 1 from the counter and then multiply this with this equation here. So just set the temporary value to the array at that index. At the counter value, like that. And then we set the array.counter to the array.index. And then we set the array.index to the temporary value. Then we just want to return the array, so return array. So that's it for the shuffle functionality. Then we just need to get a way to get the next value from the bag. So we say next int maybe. So here we just say I equals this bag, this index, like that. And then we just say increment the index. We say this index plus plus. Then we check if the index is greater or equal to the size of the bag or the randomizer, like that. Then we just want to set the index to 0, and we want to shuffle the array. And we just want to return I, of course. But the one we are interested in is getting the ID, so we can say next ID maybe. That we just return this IDSS.this.next int, like that. So that should give us the next that should give us the things we need here. Anyway, so let's figure out or clear out the bugs. So line 31, we have some errors. So let's see here. Oh, well, that was stupid. Should be like this. Sorry. What did I think there? That was really strange. Tetris line 39. Let's see, 39. Initialize, like that then. Yes. And then instead of here where we just take in the next setramino, we just want to get, say this the random.get next ID, like that. And we should now get random pieces. So the game is actually now more or less finished. But in Tetris there is you as a programmer, you don't want the user to be starting with either the S piece or the Z piece for it to be a full-fledged Tetris game. So to fix that, we can go back to the inside of the randomizer, and we just grab the two IDs from the array here. So we say S ID, and that is equal to IDS dot index of s, like that. The Z ID is equal to this dot IDSS dot index of Z, like that. It of course need to be capitalized or uppercase. So then we just here when we shuffle the array, we put this inside of a do while loop. So we say do while this bag 0 is equal to this dot SID, or zero is equal to this dot ZID. So now it will never start with the S or the Z piece, which is a functionality in all the modern versions of Tetris. You can never start with S or Z. Anyway, so the game is now actually very playable. There is no way to start in a higher level, except for like typing in no, actually you can't do that either. Yeah, but you can play the game and it works quite well, I should say. See, they update the statistics work and everything else like that. So I will leave the game for this for now, then we will do the finishing touches to it in another video in the future, hopefully. I'm really tired at the moment, so that's why I'm quitting it here. So thank you guys for watching, and I hope you learned something, and I hope I see you guys soon. Bye.